Hi, this is Mark Mosher from the Rocky Mountain Synthesizer Meet at rockymountainsynth.com. The following video is a recording from a presentation from a recent event featuring Tim Thompson, who beamed in from California. And in this talk, Tim talks about a programming language for MIDI he created some time ago and has recently recompiled for Raspberry Pi. It's called KeyKit. And if you want to see the slides for this and other talks, go to timthompson.com/talks. And you might know Tim from his work on the Space Palette or other installations which you might have seen at Burning Man or in museums. And his name is also on the back of the instrument. So without further ado, here's Tim Thompson.
My name's Tim Thompson, and I've been a programmer for my entire life, originally at Bell Labs and then recently in Silicon Valley at Network Appliance. But while I was earning a living as a software developer, MIDI was invented, and so this was in the mid-'80s. So I knew I was going to do a lot of programming in MIDI. So at that point I decided to start developing an environment and a language that would allow me to do a lot of MIDI development. So KeyKit was what I came up with. It's a textual scripting language. From day one, it was designed, exclusively for MIDI use, both algorithmic and real-time stuff. I also used it as a vehicle for experimenting with user interface things, which you'll see. So I developed it for about 10 years through a number of versions, and then after that, I started developing a lot of things with it. So it's for a programmer who's used to textual interfaces, it's very convenient and interactive, and you can make changes on the fly, which I'll demonstrate. And recently I ported it to a 64-bit CPU. So source code has been available forever, but recently I ported it to 64-bit and put it on GitHub, so it's a little more easily available. So as I said, I developed it over about a decade. Started out really basic, a lot of stuff just built in as built-in functions, but then I rewrote it so that instead of being built in, you could write functions, in the language itself. Then I started, and they were fast enough to work well. Then I added graphics. Version 5, I made a first attempt at a multi-window interface using the OpenLook Unix platform at the time. That didn't work out so well, but I added multitasking. So version 6 was another take at the multi-window interface, which worked out quite well. And that's what I'll be demonstrating. And then version 7, I added support for MIDI, multiple MIDI ports. So a little more detail on those initial points. It's a scripting language. It's multitasking, so it works very well for lots of real-time tasks, all interleaved at the instruction level. So nothing will slow down. Everything, the CPU gets shared very gracefully. MIDI data is a first-class data type. I'll show some examples of that. And MIDI input is constantly being recorded, so you don't have to go into a special mode to be recording. And I'll show examples of that. The multi-window interface is based on a very few graphical primitives, and the entire graphical user interface that you'll see is implemented in user-defined KeyKit code in the library, so you can change it, and I'll show an example of that. So it's got a lot of tools, which you'll see. So some examples of the MIDI, the syntax for manipulating MIDI. One of the most important things is that in addition to handling MIDI note on and note off, the vast majority of the manipulation is in terms of complete notes. So combining the MIDI note on and note off, and that note has both a duration and a length, and a phrase has the same thing. So having independent duration and length is actually a fairly critical aspect, which makes things work. Down at the bottom there you see this select operation that makes it a very concise way of pulling out notes from a phrase that satisfy some condition. So it was designed to make MIDI manipulation, textual MIDI manipulation, convenient. So as I said, the GUI is completely in KeyKit code. There's standard mechanisms for sharing things between the tools. And again, I'll show examples of that. So it turned into more of an environment for exploring, graphical GUI kind of things. And it's always been available with source code since '96 or so. And I said recently I ported it to 64-bit and put it on GitHub. There's executables for a number of machines, documentation. These are all the slides for this thing. I'm not going to go into a demo. But there's a much longer talk which you can find at that URL that gives a lot more examples of the code and things that have been done with it. And of course you can email me anytime if you have questions. So let's see if we can. So here's the KeyKit interface. I use pop-up menus exclusively. You can move the menus around like this, and they're nested, and you can pull off the nested menus. So there's some basic tools which are in this menu, and a much larger set of tools which is in this menu. The menus are just windows like any other window, and you can resize them like that. You can move them around. So in addition to pull-off menus, there's also pull-off buttons. I'll show an example here. Let's see. Well, that's I was going to do. Well, reread library. That's one I do a lot. So reread library. If I make a change to the library and want to reread it, I do this button. I can either select the button, or rather than select the button, I can pull it off to the right. Now I've got that button, which is a window like any other. I can resize it, and so on. So that's used a lot. I'll show many examples of that. So here you can see all these tools. The more experimental ones, the basic tools are here. So here's Kaboom, which is a drum pattern editor. So here's a menu for manipulating stuff. Here I can add randomly to this thing. So let's say I'm gonna use some of these buttons a lot. So I'm gonna pull off this Add 8 button, and I'm gonna clear a lot. So I'll pull off this button, and now I can. Those are just windows like any other, and I can range them horizontally like this. So you can create essentially toolbars on the fly. So every time I click Add 8, it's going to add 8 things randomly. Now this menu here, let's say I wanted to make a change here. You can see that a lot of these menus can be quite deep. So let's say I want to change this menu here. Rather than adding 8 random things, I want to add 4. So let's say I want to do that. So I go into the library, I edit the file that does that. So here's the code that sets up that menu. So I merely add a line here that says add, let's say add 4 there. Write that out, and now I can reread the library, and now when I create another Kaboom tool, now the random menu now has this add 4 item. So that shows you how easy it is to add things on the fly without stopping it, without disturbing your creative flow or whatever. So there's a lot of window operations to make things convenient. So let's say I create some patterns here. And let's say I like that one, so I want to make a copy of that. So I can say window, snarf that tool, and then paste it. I'll pull that off so I can do multiple ones. So I can paste it here. Let me grab the snarf as well. So now I can keep playing with developing new patterns, and anytime I get one I like, and I can snarf it and save a copy of it. And there's a lot of methods on these tools that are shared and common between the tools. So as an example, the group tool, which is the essentially the multi-track editor. Let's say I want to take this drum pattern and edit it with the group tool. So I can say window copy from this Kaboom tool to here, and now I've got it inside here, which is the multi-track editor. So now I can, let's say, pick them all and arpeggiate them, and then if I want to take that, and I can push that back into the drum pattern editor. So I can say window copy from here to here, and it's essentially populated that with a drum pattern for that. So you can see that using these tools, creating multiple copies and so on, it's designed for that usage pattern. Let's see here. So one of the interesting things on this Kaboom tool, well, let me mention on the resize, if I'm going to resize this window, rather than sweeping it out like this, I can just click without sweeping it out and it'll fill that area. So that's a very convenient thing that lets you throw these windows around quite easily. So here's the Kaboom tool. So rather than these buttons, these cells being all on and all off, I can make them essentially be little sliders so that it won't always fire on that cell. It'll this one would fire at 50% of the time. So you can do this. So in addition to using this to manipulate the probability of it firing, you can also manipulate the brightness and other attributes of it. Another feature of this is that, let's say I've got this, and I want to put some. So I've got a keyboard here in front of me. So let's say I play some notes here. So I can make this row be that. Be that chord. I can, while it's doing that, I can play another chord there. So, and that's an example of using the fact that it's always recording. So it's always recording. So in this menu here, I can say, use whatever the last, sequence of notes that were recorded. And a lot of the different tools use that to good advantage. Let's see. So that's that. There's also pages, so if I run out of room here and I don't want to, resize things, everything resizes to any size. So, I can make this Kaboom tool super small. But you also have pages, so I can do a new page, and then you can switch back and forth between them. So one of the interesting tools is Espresso, which is a L systems fractal kind of thing. I won't go into detail on what it's doing, but you'll notice that this tool has a lot of buttons up here, but this here is actually the group tool, the sequencer, reused. So here's the normal multi-track, editor, and here it is embedded inside this tool. So there's a lot of examples of using that. Here's a tool which there's a smaller tool called the riff tool, which is just a simple one phrase thing, and here's a tool which uses 4 of them, and you can load. Let's say I'll play that chord and I'll load it in that one. So now every time this line hits that side, it'll fire that phrase. So again, these are just tools I create. One night I have an idea for a weird tool, and there's a lot of them in there. Let's see. Joy Balls is one of the more fun tools. Let me get this out of the way. So I'm going to load a file in here. So it's taking the notes of that MIDI file and assigning them to the walls of this big grid. And now I can place a ball. You see the red ball there. So now every time it hits the wall, it plays whatever note or phrase is on that wall. And I can break down the walls, and this actually works fairly nicely in a musical sense, because music is lots of repeated things. So so the different colors here, you've got 3 different colors, and each one's a different channel, and you can control the velocity and energy and whether they slow down or not. And there's, of course, lots of menu items here. I can turn on a breakout mode so that rather than the balls being confined to their cells, I turn that on. So now they're breaking down the walls and as they move around. Let's see. You can limit the number of balls. So there's lots of fun stuff you can do with this one. So this is gives you random walls, whether you want to cover 50% or 20%, and so on. So that gives you a flavor of some of the things. Let's see this. How am I doing on time here? Gene pool is one that, let's see. So I took a Bach MIDI file, split it up, 1 beat sections. Each one goes into a cell. And now I can, there's a genetic algorithm that will mate these cells. So if I click the right mouse button, I kill the current value of that cell, and it mates the other cells and generates a new one. So you can very quickly, do things and audition them, and that's what it's built for. Is a lot of algorithmic stuff, and a lot of algorithmic stuff doesn't sound musical, or it depends on your taste. But the key is to be able to do things quickly and audition them, and then filter them with your own taste. Let's see. Markov Maker is another one here. So I'll again read a MIDI file and initialize. A Markov model tries to make things that are similar to other things. So here I'm breaking up this original MIDI file into sections which are half a beat wide and incremented by a quarter beat, and then I'll make a similar one. So here's the original, and here's the and of course, if I wanted to manipulate that, let's see. I wonder whether a window copy will work here. Yeah. Let's see. So that gives you a pretty good sense of the flavor of things. I think I'd like to open it up for questions, or if somebody wants to ask, I'll show the
Sure.
full list of tools.
Hold on just a sec. So we're still recording this. So let me just ask you a couple questions, Tim, and then we'll open it up to the room and maybe stop the recording. Real quick though. So what year did you say you created this? What the original version was? What year?
Well, I started on the Atari ST in 1985 or so, and it's been ported to a ridiculous number of machines. Only a few of them have been well supported because they're the ones I use. So Windows, or I mean, it started out on DOS. So DOS. So I had to make it work in very small address spaces and with slow machines. So nowadays it just screams. And so I worked on it for about 10 years, developing it to this point. So this is basically identical to what I had in 1995. And then since then I've mostly just used it to develop lots of things. Oh, I can show you. Let's see here. I do a lot of installations at Burning Man.
Yeah, that was going to be my next question. Is where have you implemented this? In what projects have you ended up, using it in? Maybe no, probably a lot, but what highlights?
Yeah,
maybe?
I mean, you can look the other. Let's see, I can show this thing. I mean, stuff. Doing a real-time performance from a keyboard. At Burning, this is the first year at Burning Man, some dance pad stuff, and then the next year I did this thing. So that thing you saw here is basically an emulation of what I did in real life here. So these are dance pads here, and people are, triggering notes and loops, and the MIDI was controlling. I had a MIDI to RS-232 or MIDI to relay thing. So I was turning on and off these rope lights according to the notes of the music. And this is back long before LEDs became popular. So this is 120 volt rope lights.
It's awesome. All right, let me open it up to the room here. I'm going to. Oh, sorry. Did you have more you wanted to show?
No, keep going.
Okay. Let's see.
Oh, real-time MIDI output. I mean, everything's real-time MIDI output. I'm looking at the chat thing.
Sure.
Files. I mean, this is all MIDI. I don't do any audio processing. So the sounds you're hearing are from soft synths that I'm sending MIDI to. So KeyKit is MIDI only, and that's it. Some of the other things that other people have done with it, I'll show. Where was that? Oh. So this guy did some incredible stuff, lots of algorithmic stuff based on geometries of these things.
Hi, it's Mark again. At this point, I stopped the recording for Tim because we went into a breakout session, and I wanted to protect the privacy of the people who were in the call. So I hope you enjoyed Tim's talk. And again, you can learn more about Rocky Mountain Synthesizer Meet at rockymountainsynth.com and Tim Thompson at timthompson.com. And you can get his talks at timthompson.com/talks. Thanks for watching.